CHFCA hosted webinar. Before we get started, some housekeeping items. Thank you, Chris. First, CHFCA webinars, we follow competition law compliance policies, so please refrain from disclosing any confidential information. Remain muted throughout the session if you're not speaking, and feel free to write your questions in the Q&A box below. We will be asking the questions at the end of the webinar. Today, we will have the pleasure of introducing one of our industrial members at CHFCA, SFC Energy. SFC Energy has recently launched their fuel cell hydrogen products in Canada. SFC Energy is a leading supplier of direct methanol and hydrogen fuel cells for stationary and mobile hybrid power solutions. With over 45,000 fuel cells sold worldwide to date, SFC Energy is a sustainably profitable fuel cell producer. The company is headquartered near Munich in Germany, with offices in Calgary. Speaking on behalf of SFC Energy today, we have Chris Wallen. Chris is the Director of Clean Energy at SFC Energy Ltd and has worked in off-grid power business for at least 16 years. He has designed and sold eco-friendly off-grid power systems for a number of industrial applications all over the world, and he is based in Calgary. Chris, welcome.
Thanks very much, Yvette. Hi, everyone. Thanks very much for joining us today. I'm excited to share some information about our hydrogen fuel cells and EFOY hydrogen energy solutions. Like Yvette mentioned, feel free to add your questions into the Q&A section, and we'll try and go through as many of them as time permits at the end of the webinar. All right, so a brief introduction to SFC Energy. Like Yvette mentioned, we're based in Brunfeld, Germany, just outside of Munich, and we're a global leader in fuel cell technology and off-grid energy solutions. So over the last 23 years, we've deployed over 62,000 fuel cells around the world. And in that time period, our fuel cells have operated for over 130 million operating hours, produced nearly 10 megawatt hours of clean energy, and eliminated over 5,100 tons of CO2 emissions. SFC Energy North America, formerly Cymark Controls, was acquired back in 2013 and serves as our North American headquarters here in Calgary, Alberta. So, brief introduction to hydrogen. For those of you that aren't aware, hydrogen is the most abundant element in the universe and accounts for about 75% of all matter in the universe. That being said, it rarely exists as a gas on Earth and typically needs to be separated from other elements, utilizing a number of different processes and power sources. If you look at hydrogen, it's definitely a clean alternative to fossil fuels, as its combustion produces only pure water. Looking at the different types of hydrogen, so like I mentioned, hydrogen emits only water when it's combusted, but creating it can also be carbon intensive. So there has been various ways to lessen the carbon impact developed, and there's colors used to distinguish between them, with the most common being gray, blue, and green hydrogen. Gray hydrogen is the most common form and is typically generated from either natural gas or methane through a process called steam reforming. Blue hydrogen is also produced through steam reforming. However, the CO2 that's produced is also captured and stored using carbon capture and storage, making it carbon neutral or low carbon. And then there's green hydrogen, which is produced through a process called electrolysis, powered by renewable energy. And this has been hailed as the clean energy source for the future. So since renewables cannot produce power 24/7, using electrolysis to produce hydrogen can help us use the excess power generated during peak production to help harmonize the intermittency of renewables. And there's various other colors of hydrogen out there as well, from white hydrogen, which is naturally occurring hydrogen that's sometimes found underground, black or brown hydrogen, which is produced through coal, and various other colors produced using electrolysis powered by nuclear energy as well. If we look at Canada's overall hydrogen potential, so Canada's vast natural resources put us in a really strong position to be a top global hydrogen producer. And depending on the region, we have the ability to utilize a mix of fossil fuels, hydro, renewables, nuclear, and mixed feedstock for producing hydrogen. Digging into Canada's vision for hydrogen. So Canada's 2050 vision for hydrogen includes 30% of our energy supply coming from hydrogen, a large distributed domestic supply of low-cost clean hydrogen, and over $50 billion in revenue for the Canadian hydrogen sector. So this affords significant opportunity to use hydrogen fuel cell energy solutions in various applications. So combined with Canada's hydrogen production potential, our hydrogen market overview in the near term and long term also looks very promising. The Canadian government has committed under the Paris Agreement to reduce our GHG emissions by 30% by 2030. And the hydrogen strategy for Canada is working to put in place foundational federal initiatives over the near, mid, and long term that will enable us to achieve our vision for hydrogen by 2050. This includes electricity and low carbon fuels, accounting for up to 60% of our energy needs. And this will help us decarbonize the top third of Canada's most energy intensive applications. So beyond that, the government's also provided some pretty strong funding backing for the clean energy transition. In the 2022 fall economic statement, the Canadian government announced an investment tax credit for both clean technologies and clean hydrogen to further incentivize the adoption of clean energy technology in the pursuit of net zero. So the clean technology tax credit covers 30% of the capital cost of eligible equipment, while the clean hydrogen tax credit covers up to 40% of the capital cost of products that meet the carbon intensity eligibility requirements. Both of these tax credits are now available as of the release of the 2023 budget on March 28th, and will provide a $6.7 billion investment into clean energy development over the next 5 years. Moving on to SFC. So back in 2020, SFC Energy acquired the rights to an existing hydrogen fuel cell technology and has since worked to improve the design and secure the necessary certifications to bring this technology to new markets like North America. And with an install base of over 1,000 units in Europe, our field-proven hydrogen fuel cell technology provides zero-emission clean energy in 2.5 kilowatt modules that can be parallel together up to 50 kilowatts. Looking at the fuel cell operation itself, so hydrogen fuel cells produce electricity without combustion. So that means, unlike internal combustion engines, they generate little, if any, noise, vibration, pollution, or greenhouse gases, and are able to operate at very high efficiency over a wide range of loads. Unlike batteries, the amount of energy autonomy that can be produced by a fuel cell is limited only by the amount of fuel that they can operate, that they have to operate. So they can operate continuously as long as fuel is available. The fuel cell stacks themselves have catalyst-coated membranes sandwiched between two plates to make a single cell, with numerous single cells combined to make a stack that produces the required amount of power. So in our case, that's 2.5 kilowatts. During the operation, hydrogen is fed onto one side of the stack and oxygen onto the other. The hydrogen splits into a proton, which goes through the membrane, and an electron, which is captured and used as electricity. The proton and electron then combine with the oxygen on the cathode side to produce water and heat, which is expelled as pure water vapor, making it a zero-emission device. Our EFOY hydrogen fuel cell effectively acts as a smart automatic battery charger with a set switch on and switch off voltage threshold. So the fuel cell is always connected to a battery bank to handle any peak or intermittent loads, as well as to ensure seamless power transition in the event of a grid power failure. The fuel cell turns itself on and off automatically once the battery voltage drops to the set switch on voltage and goes back into standby once the battery voltage is brought back up to the switch off voltage. The core components of the fuel cell system itself are the 2.5 kilowatt fuel cell units and the hydrogen controller or master control unit. So the fuel cell unit is a 2.5 kilowatt module that produces 48 volt DC power, and multiple fuel cell units can be clustered together to produce clean, reliable power up to 50 kilowatts with long autonomy and little to no maintenance. The hydrogen controller itself is the central control device for the various components of the system. So it controls the parallel operation of up to 4 fuel cell units together, in addition to controlling the 48 volt output and the switching on and off of the fuel cell as required when the voltage thresholds are reached. Another feature that we're working on developing similar to our methanol fuel cells is a cloud-based remote monitoring and control platform. So this allows users to remotely monitor the status of their hydrogen energy solution, change any of the operational parameters remotely, set up alarming to be notified in the event of an error or when it's time to refuel. And this allows users to proactively plan their refueling and never run the risk of running out of fuel on site. Now, looking at the primary applications for our EFOY hydrogen energy solutions, these are emergency backup power for critical grid connected applications and primary hybrid power for off-grid applications. So in an emergency backup power scenario, the fuel cell is connected to a battery that is float charged by the grid until there's an outage, at which point the battery voltage drops and engages the fuel cell to start to maintain the battery until the grid power can come back online. Most critical applications are mandated to have at least 72 hours of autonomous backup power to ensure there's sufficient time for the grid power to be restored. And trying to tackle this with battery backup alone can require a pretty substantial battery bank, and running diesel generators to provide backup power can be challenging as well because they don't often turn on when they've sat in standby for too long if they're not maintained properly. And then if we're looking at a hybrid primary power scenario, this is where the EFOY hydrogen fuel cell would be paired together with solar and or wind to charge a larger common battery bank, which would provide power to all of the site loads. The solar and wind would be sized to carry the loads and maintain the battery bank during the parts of the year when enough production capacity is available. And the fuel cell would turn itself on and off as required to provide supplementary power to cover any production shortfalls during the fall and winter months or during periods of bad weather, ensuring that the battery zero is maintained and the site loads never are short of power. If we look at a sample hybrid power calculation that includes solar, wind, and fuel cell input, we see that the load demand at the top in dark blue is jointly covered by all 3 power sources at different ratios throughout the year. So solar power availability is always the strongest in the spring and summer and can drop off quite substantially in the winter months, while wind power is typically a bit better in the colder months of the year and helps make up for some of the drop off in solar. The fuel cell itself monitors the battery voltage and sits in standby mode until there's insufficient input from the solar and or wind, and the battery voltage drops to the switch on threshold. At that point, the fuel cell would turn itself on, provide supplementary power as required before going back into standby mode once the solar and wind is sufficient again to maintain the batteries. So this type of operation is extremely efficient as the fuel cell only operates when required and can also load follow to only provide as much power as required. This allows you to better handle any peak or intermittent loads minimize your hydrogen consumption, and streamline your overall OpEx costs. On the other hand, if you were to use a gas or diesel generator to provide the same power to the load, they need to either be on or off at all times. They can't load follow, and they're not really designed to cycle on and off in a hybrid configuration. So this can lead to significantly higher fuel consumption, maintenance, and operating costs. So if we look at potential future applications for the hydrogen fuel cell, we could also add an electrolyzer into the mix to generate hydrogen on site with any excess power generated from solar and wind. And this can be used to mitigate the intermittency of the renewable energy production. So SFC Energy is currently working with a few different electrolyzer manufacturers to evaluate this type of scenario, and we hope to have a viable solution that works efficiently for suitable applications in the coming years. When it comes to the hydrogen itself, our fuel cells require hydrogen 3.0 or better, which means 99.95% pure. And most industrial gas suppliers have higher purity fuel cell grade hydrogen at 4.0 or 5.0, or even lab quality hydrogen at 6.0, meaning you can easily source the required grade of hydrogen from suppliers like Linde or Air Liquide or any other industrial gas supplier. So overall, our EFOY hydrogen fuel cells consume roughly 0.06 kilograms of hydrogen per kilowatt hour of energy produced, meaning that every 1 kilogram of hydrogen provides just over 16 kilowatt hours of energy production. The standard type 1 steel 50-liter cylinders at 300 bars contain just over 1 kilogram of hydrogen. And this amount can vary depending on the bottle pressure, which can range anywhere from 150 to 350 bars for the type 1 cylinders. If you look at a standard 16-cylinder bulk pack, this provides enough energy density to run a 10 kilowatt load for just over 24 hours, and these can be parallel together to achieve your desired level of autonomy. So in an emergency backup power scenario, you could parallel 3 of these together to provide more than 72 hours of backup power for your 10 kilowatt load. And looking at primary power applications that require a larger volume of hydrogen, there's also options out there that utilize carbon fiber wrap type 3 or type 4 cylinders that are lighter and can accommodate higher pressures. This allows you to store a much higher density of hydrogen in a similar space. And these options are available from various suppliers and allow you to provide enough autonomy to run a fuel cell solution autonomously for months or years at a time as required. So over the last few years, the product team at SFC Energy have focused our development efforts on designing a handful of standard solution offerings. These include our N-series indoor and X-series outdoor hydrogen cabinets, as well as our H2 genset platform that will be available in the coming years. The N-series cabinet can be deployed inside any building and connected to an external hydrogen supply, as well as be integrated into a modular hydrogen shelter-based solution. The X series, on the other hand, is meant to be deployed outside as a standalone system, and this would be connected to a hydrogen supply, whether it be a bulk cylinder pack or a skid, located next to the cabinet as required. So if you look at the core design of both our N-series and X-series cabinets, they are meant to be the same, with the ability to parallel up to 4 of the fuel cell units together in a single cabinet to provide up to 10 kilowatts of output power. And beyond the fuel cell units themselves, the cabinet also includes the hydrogen controller, which controls the parallel operation of the fuel cells, the 48-volt DC battery bank and DC power distribution, any AC inverters as required, the air intake and exhaust fans, cabinet heaters, hydrogen pressure reduction to step down the inlet pressure into the fuel cell, as well as the ability to connect to a suitable external hydrogen supply to give you enough autonomy as required. So building off the core 10 kilowatt cabinet, we also have the ability to cluster multiple cabinet sections together to provide up to 50 kilowatts of output power as required, along with additional cabinets for inverter equipment if needed to provide single phase 120 or 3-phase 208 or 480 volt AC output. So these core building blocks allow for flexible integration into buildings or into modular CCAN based shelter solutions that can be deployed in remote locations. And the H2 shelter solutions that we're working on will be able to accommodate up to 20 kilowatts of output in a 20-foot CCAN or up to 50 kilowatts in a 40-foot CCAN. So looking at our EFOY hydrogen energy solution roadmap timeline, we are planning to have our X and N series cabinets available for sale within the coming months, and plan to be able to deliver our first systems to customers by Q3 of this year. Our H2 shelter is currently going through the detailed engineering phase, and we hope to have the initial shelter built in Q3 and tested throughout the coming winter. So assuming we don't run into any roadblocks, the 20-foot shelter solution will be available for sale by the end of 2023, with deliveries into the first part of 2024. And then finally, we are evaluating an H2 genset platform with and without onboard hydrogen storage tanks, and anticipate that this solution will be available sometime in late 2024 or into early 2025. So looking at the overall market opportunity for our hydrogen energy solutions, we believe there's a major opportunity to replace diesel generators in a variety of different markets and applications, providing backup to critical infrastructure and primary power for remote off-grid applications. So in addition to being able to serve higher power applications in the oil and gas and mining sectors that we're familiar with our methanol solutions, we also see a very good fit in the telecom sector with nearly 400,000 cell tower sites operating between Canada and the US that are currently either powered by or backed up by diesel generators. Beyond this, there are over 280 remote communities in Canada not connected to the electrical grid. The need to electrify long distances of remote highways, like the Alaska Highway, a growing need to support utility peak shaving for various electrical utility providers, and numerous other applications where industries will continue to move away from diesel power generation in order to reduce their emissions and achieve their ESG goals. So looking at some examples of solutions that have been deployed over in Europe, this is an example of a 10 kilowatt N series indoor solution for one of our customers in Italy. You can see that the exhaust is piped out of the building through HVAC ducting, and the system is connected to an external hydrogen supply located outside of the building as well. This picture is the largest solution that we've installed to date, and it is a 50 kilowatt N-series solution located at a green hydrogen production facility in Austria. So this system backs up all of the critical infrastructure in the facility and is also used to generate power to sell back to the grid whenever they have excess hydrogen available that needs to be used up. And in this case, you can see there's 5 cabinet sections for all of the fuel cell equipment, along with a 6th section that includes all of the inverter and power distribution equipment. So moving on to the X series outdoor cabinets, this is a 5 kilowatt solution that was installed for Deutsche Bahn, the German rail company, And this was used to power the rail signaling and switching gear. Finally, here's another 5 kilowatt X series outdoor solution. This is installed for emergency backup power for the Tetra digital radio systems network, which is located in several countries throughout Europe. Altogether, thus far, more than 500 of these systems have been installed for this project, with up to 1,500 systems planned to be installed in the coming years. So moving on to the value drivers of a hydrogen fuel cell. So looking at a hydrogen fuel cell solution in place of a diesel generator, the biggest driver is obviously around emissions reduction. So if we look at a 5 kilowatt diesel genset, it produces nearly 46 tons of CO2 emissions a year, versus a zero emission hydrogen fuel cell generator. You're saving 46 tons of CO2 emissions, which is the equivalent to nearly 250,000 kilometers driven by a diesel vehicle. Digging into that a little bit further, so same thing, a 10 kilowatt diesel genset, if it's operating continuously throughout the year, consumes almost 36,000 liters of diesel and produces nearly 100 metric tons of CO2 emissions. And beyond that, if you look at in Alberta, the Alberta carbon tax and federal fuel charge cost to operate a 10 kilowatt diesel generator over a 10-year period amount to over $100,000 in cost. So, a hydrogen fuel cell is going to operate significantly quieter, require minimal maintenance, have no power degradation while in standby mode, and can work in conjunction with renewable energy sources like solar and wind to provide zero emission energy, eliminate all those emissions, all that fuel consumption, and save all the costs when it comes to the carbon tax and federal fuel charges. So overall, at scale, a hydrogen fuel cell solution can provide a substantial reduction in CO2 emissions and in cost savings in any application where diesel generators are typically used. So in conclusion, the main value drivers of our zero emission EFOY hydrogen energy solutions are that the safe hydrogen supply and handling is a solved problem. You can get fuel cell grade hydrogen from any industrial gas supplier. There's no power degradation of the fuel cell stacks over time when they're in standby mode. So in a backup power application, the fuel cell systems will basically last for the life of the system. The hydrogen itself can be stored over many years in suitable tanks, and it can also be used in environmentally sensitive areas. So one big value that we see is that there's no risk of environmental contamination. If there ever was a leak with hydrogen, it's going to vent to atmosphere and it's completely harmless. It's not like having a big diesel tank on site where you have to worry about spill mitigation. And then finally, our hydrogen energy solutions produce zero GHG emissions, with the only outputs being water vapor and warm air. So this is going to be a big catalyst to help companies out there move away from solutions like diesel generators and eliminate CO2 emissions and save on costs like carbon tax and federal fuel charge costs. Yeah, thanks to everybody for attending today. Hopefully there was some useful information in there. We're really excited about our hydrogen energy solutions and the different applications that we're going to be able to tackle with these things. So any other questions that you might have, don't hesitate to reach out directly to myself or anyone from our sales team, and we'll be happy to get back to you guys with more info. We are looking for industry partners to pilot systems in the second half of this year, or to deploy initial systems for different applications. So if you have something that you think might be suitable and is within the 2.5 to 50 kilowatt power range, please reach out and we'd love to chat with you about it more.
Excellent. Thank you very much, Chris. Thank you very much to the SFC team behind the scenes, Dania and Ayana, for making sure everything worked smoothly. And before we leave, well, thank you to the audience, of course. And if your company would like to be featured in a future CHFCA webinar, please reach out to me or to our Director of Operations, Nicolas Hilario. And with that, we thank again Chris and SFC Energy and everyone listening. Thank you very much.
Thanks, everyone.
Thanks.
Take care.